High-speed sample and hold circuit. The introduces sample and hold circuit is an important analog building block with many applications including analog to digital converter. The function of SMH is to sample an analog input and hold the value over a certain length of the time for the subsequent processing. The alternative CMOS of a sample and hold circuit sample and hold section covers the three alternative CMOS that are developed in the intentions of the minimum charge injections or the clock phase. Series sampling SPH often classified to the parallel sampling because the hold capacity is parallel with the signal. In parallel sampling, the input and the output are decoupled. In other hand, the SNH are shown in the figure. Switch op-amp based the sample and the hold circuit. The SNH takes the advantage to the fact that when a MOS transistor is in the saturation region, the channel is pinched off, disconnected from the drain. Therefore, if the hold capacitor is connected to the drain of a MOS transistor, the charge injections will go to the source, leveling a drain unaffected based on the concept of a switch op-amp. Successive approximation ADC. This is also called as a bit weighing conversion system. ADC conversion technique based on the successive approximation resistor applied input voltage against the output of an n-bit and the analog converter. The final result is obtained as the sum of n weighing steps in which each step is single bit conversions using DAC output and the SAR converters. Integrating ADC. In an integrating ADC, the current proportional to the input voltage changes in a capacitor as are fixed. At the end of the interval, the device resets its counter and applies the opposite polarity negative reference to the integrator. Because of this capacitor, it's discharged by a constant current until the integrator. This type of ADC is extremely slow device for the low input bandwidth. Single sigma delta ADCs. It consists of two main parts, modular and the digital filter. The modular oversamples the input signal converting to the serial bit stream within frequency. This is the transform to the output filter to the sequence of parallel digital words. Typical applications are for a speech and audio. Analog to digital using a voltage time of conversion. Here the cycles are variable frequency source are counted for a fixed period. It is possible to make an A/D converter by counting the cycles of fixed frequency source for a variable period. For this, the analog voltage required to be converted to a proportional time period. So A/D using a voltage to time conversion. This is the block diagram. As shown in the diagram, the negative reference voltage minus VR is applied to the integration whose output is connected to the inverting input to the comparators. The output of the comparator 1 as long as the output of the inverter VO. So when VNS goes high, the switch S is closed. Thank you.